Glucose. It's everywhere in my blood, your blood, and even my cat's blood. It rises when you eat, drops when you fast or exercise, and your body works very hard to keep it in a particular range with a little help from the mineral chromium. Now, some of you might associate chromium with a particular movie about environmental contamination and think, wait, isn't chromium toxic? And you'd be right. One form of chromium is a carcinogen that damages your DNA and has absolutely no place in your body. But today I'll be talking about a much more friendly form of chromium that's found in food and supplements. Normally, the carbohydrates in food that we eat are broken down into the sugar glucose by stomach churning and enzymes. This glucose then moves into the blood. To counter this, your pancreas secretes the hormone insulin, and chromium makes your cells extra sensitive so that when insulin binds to them, lots of molecules inside the cell, called glutes, come to the cell's membrane. These glutes move glucose into the cell, providing it with energy and reducing the amount of glucose in the blood. However, in people with type 2 diabetes, there's not enough insulin to go around and cells aren't as sensitive to it as they should be. Some glucose still gets taken into the cell, but it's not enough to give the cell all the energy it needs, and that extra glucose that gets shut out gets stuck in the blood. And that's what we call high blood sugar. So, chromium's role in boosting insulin sensitivity has led many people with type 2 diabetes to consume supplements with it in hopes of showing their stubborn blood sugars who's boss. But medical professionals and scientists are divided over whether chromium supplements actually do anything. Chromium's relationship with blood sugar was investigated in the United States in the 1950s using rodents. In the 70s, investigations in humans started when a hospital patient receiving nutrition through an IV developed symptoms of diabetes that just couldn't be managed by insulin. However, upon being given chromium, the patient's blood sugars went down and they no longer needed insulin to manage them. And because IV nutrition solutions at the time didn't contain chromium, scientists figured that this patient's diabetes was caused by a lack of chromium. And this, some claim, is where chromium's role as a supplement ends. If you're already consuming an adequate amount of it, then taking extra just isn't going to help your blood sugar. And because of the abundance of chromium in so many different kinds of food sources, as well as its addition to special nutritional formulas and solutions, pretty much everyone gets enough of the mineral. Authors of a 2014 review paper insist on this, arguing that studies that do show that chromium can lower blood sugar tend to be poorly designed or even sponsored by manufacturers of chromium. One study these authors are particularly critical of is one showing that dosing of chromium for 4 months in people with type 2 diabetes lowered their hemoglobin A1Cs from 8.5% to 6.6%. An A1C is like a diabetes report card that shows your average blood sugar over the past few months. And an average goal is about 7% in people, so that drop is like going from a D- to a B. However, some of the people in this study knew who was getting treatments and who wasn't. And when you know that kind of information in a study, it can affect the way that you act and behave and therefore also affect the results of the study. That's only one review though, and the studies it looked at all featured different kinds of chromium given at various doses and for different lengths of time. And when those characteristics are inconsistent between studies, it can be a bit difficult to make a general statement about whatever it is you're investigating. So to get a better idea of chromium's usefulness, it might help to look at reviews that evaluate more similar studies. And a 2013 review did just this and looked at hemoglobin A1C in addition to fasting blood sugars. And a fasting blood sugar is basically just what your blood sugar is when you haven't eaten in a while, like say when someone checks their blood sugar before a meal. And on average, these trials did show that chromium was able to lower fasting blood sugars. Yet, it wasn't able to lower hemoglobin A1C. And that's a bit of a problem because fasting blood sugars, say, checked with a meter at home, only reflect in-the-moment values. They don't reflect averages. And so having lower fasting blood sugar levels but ending up with the same hemoglobin A1C is like doing better on a few homework assignments in a class but still ending up with pretty much the same final grade. Plus, although this study wasn't as varied as the one from 2014, the studies it looked at still weren't identical. Some of them featured a form of chromium called chromium picolinate, while others used yeast enriched with chromium. And the months that they lasted also varied too. These study lengths are particularly troubling because type 2 diabetes is a chronic disease that many people live with for years or even decades. So looking at chromium over the course of a few months doesn't really tell us what it's going to do over the span of many, many years. Now, while drops in fasting blood sugars alone don't really give chromium much credibility, there is another metric we can look at: after meal blood sugars. You see, blood sugars tend to be highest in the hours following a meal, and sometimes insulin struggles in controlling these after meal blood sugar spikes, even if it still manages to keep blood sugars down at other times of the day. And because hemoglobin A1C is only an average, it can't tell you what your blood sugar was, say, on April 18th, 5:35 p.m. It only gives you an average. Researchers investigated this in a 2020 trial in which they gave participants a meal along with a drink containing a mixture of chromium and amino acids, and then monitoring their blood sugar for the next 3 hours. And in participants who drank the supplement, their blood sugars were, on average, 6 milligrams per deciliter of blood lower than participants who drank a placebo for about an hour and a half after the meal. And although 6 milligrams isn't a huge difference, it's still something. Yet these changes were only seen in blood sugar measurements taken from blood from a vein. They weren't found in, say, capillary blood sugar that you measure at home with meters and finger sticks. Plus, the drinks in this investigation contained both chromium and amino acids, so it's impossible to tell whether it was the chromium or the amino acids or mixture of the two that actually lowered blood sugars. Oh, nobody in the study actually had diabetes. They were all non-diabetic. Not all hope may be lost for chromium, though. A 2017 study looked at a bunch of trials and found that, on average, chromium was able to lower fasting blood sugar by 18 milligrams and hemoglobin A1C by 0.5%. And on top of that, the study also looked at different forms of chromium, something that the other studies that I talked about earlier didn't really delve into. And what they found was that chromium picolinate was able to lower both fasting blood sugar and A1C, while yeast enriched with chromium was able to lower just A1C. But the kinds of people who took part in these studies were all over the place. Some studies just wanted their participants to have type 2 diabetes, while others had very specific requirements for what hemoglobin A1C participants could have. And some studies wanted their participants to be using insulin or oral medications, while others wanted absolutely nothing to do with medication at all. And so, someone who's, say, doing really well with just diet and exercise probably isn't going to respond to chromium the same way that someone who's struggling even with medication is. And so when you average results of these studies that have wildly different participants, it just becomes really, really unlikely that everyone's type 2 diabetes is going to respond to chromium in the way that these averaged results suggest. With these really conflicting results in humans, you might wonder, well, what do animal studies have to say about chromium? In 2014, researchers pointed out that, on average, studies using rodents do tend to show more success with chromium than studies with humans. And this could be due to a difference between rodent and human biology. However, the authors suggested that this could also be an issue of quantity. Rodent doses, when scaled to human weight and metabolism, were anywhere from 2 to 50 times as large as typical human doses. So perhaps chromium can help, but we're not giving it in large enough amounts. All that being said, is it actually worth taking a chromium supplement? Is it going to help tame any belligerent blood sugars or stop any hyperglycemic house parties? Well, besides people who are chromium deficient, no, not particularly. There's lots of different forms of chromium that might require different doses and different lengths of time to produce any effects on blood sugar, if they can actually affect blood sugar. Plus, not every effect matters the same, and not every case of type 2 diabetes is going to respond to chromium the same. If we really want to get to the bottom of things, we have to conduct a bunch of studies using the same kind of chromium with very similar doses for a very similar length of time, using very similar participants, and then all those studies have to be looked at together and averaged. But until we do that, we just have a bunch of different studies that don't really paint any kind of coherent picture. So, if you have type 2 diabetes and have also been diagnosed with a chromium deficiency, then by all means take a chromium supplement. Your pancreas is really going to thank you. But as for the way bigger chunk of type 2 diabetics who are chromium adequate, you're much better off just keeping vigilant with regular exercise, eating a consistent carbohydrate diet, and taking any oral medication or insulin regimens you've been prescribed. Mauser, say hi to the camera. Say hi to the camera.